Alright guys, this is going to be a very, very brief review on the periodic table and their families. This is going to be very brief because this is all material you should have seen at some point, and we're just going to review it so that you remember it if you have forgotten. So when we look at the periodic table, we have rows and then we also have groups. So the rows are the horizontal rows, and then we have groups, which are also called families, which go up and down. Now rows, remember, the row number will give a reference to the energy level that the valence electrons are on. So if it's on a row 4, the valence electrons are on energy level 4. Now the groups and families, well, they're called families because they have very similar chemical properties. So that is because they have very similar electron configuration. So everything in group 1 ends with S1. Everything in group 2 ends with S2, so they all react in a very similar fashion. The main group elements, those are our S and P block elements. So if you hear the term main group elements, it's talking about something in the S block or something in the P block. Now group 1, they are more specifically the alkali metals. They are the most reactive. Now hydrogen is not technically an alkali metal. It is there because its configuration it matches it. So the alkali metals are the most reactive metals because the ionization energy is so low and it's easier to remove that one valence electron. Now then we have our alkaline earth metals, which is group 2. Those are our second most reactive metals. Then we have our noble gases, which are as group 18 or 8A, and those are the most unreactive nonmetals. And then we have our halogens, which are our most reactive nonmetals, and that's group 17 or 7A. Now then we have our D block. Our D block has our transition metals. Now there are actually a few metals in here that are not considered to be transition metals, like zinc. So our transition metals are in our D block. The properties are very varied. They're very different from each other. Now, a lot of these elements are used in organic reactions as catalysts, and they also make colored complexes. So basically, if you have an ion with that is a transition metal, if you have a transition metal ion in a solution, it will be colored, except for zinc, which is one of the reasons it's not considered to be a transition metal. Then we have our inner transition metals, which are the very weird elements. Those are our lanthanides and our actinides. So we have the lanthanides on top, the actinides on the bottom, and all of these are very rare, and a lot of these are unstable. For metals, so we have metals, we have nonmetals, and then we have metalloids. Metals are on the left side of the table, except for hydrogen, of course, and they have similar properties. So they're all, or mostly, lustrous, so they're shiny, they're ductile, which means you can pull it into a wire, they're malleable, and they're good conductors of heat and electricity, and all of these properties are basically due to the fact that they make metallic bonds. Now metals will also form cations, which means they lose electrons to become positively charged. So now, if we're looking at metals, because they have lower ionization energies, they are often oxidized in reactions. Basically, that means that they lose electrons. So when we have a metal, they will become cations, never anions, because it's easier for them to lose electrons than to gain the electrons. Now, metallic characteristics of the elements actually increases as we go down and to the left. Now, this is a trend that you can see a lot of discrepancies in, but in general, it increases to the bottom left corner. Now, our nonmetals are going to be on the right side of the table. Now, we actually don't have that many nonmetals. Most of our elements are metals. So they're on the right-hand side of the periodic table. Don't forget about hydrogen, though. And they are good insulators. They are usually gases, or they're brittle solids. So you'll see things like neon, sulfur, iodine. Now, something you should remember is you have some nonmetals that come as diatomic elements. So all of your, or most of your halogens will come as a diatomic molecule, which means they come in a pair. And this is important for when you write equations, so it's something that you need to remember. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So the Brinkelhoffs are our diatomic molecules. So you need to remember that. All right, so metalloids. Metalloids will be somewhere in between a metal and a non-metal. So these are the ones located on the staircase. So the staircase goes from here, like that. So basically every element that touches the staircase, except for phosphorus right here, and also tin right here, those elements are considered to be metalloids, which means they will have some characteristics of metals and some of non-metals.